All right, we're starting a new section today, and that section is roughly on health and public health. And so today we're going to talk about some background of that we'll need to understand COVID-19, and hopefully that will allow us to understand some of its disparate impacts later on. This background is going to be what diseases are, how diseases have affected humans throughout history, how we categorize them. We'll talk a little bit about COVID-19, and this is going to be extremely time sensitive. Um, so maybe I will make that a separate video. And then we will talk about COVID-19 and climate change to show you that there is a deep connection between everything. The fundamental interconnectedness of all things. The previous section leads to this section leads to every section, so on and so forth. There's been a lot of views about what diseases are historically. And when we trace the history of these theories, we typically go back to the four humors view proposed by Hippocrates in 400 BCE. But there are lots of other views that are, quote, just as scientific, proposed throughout before, during, and after. Right, that perhaps diseases might be caused by spirits or sudden emotions or curses or magic. Hippocrates thought that diseases were caused by an imbalance of liquids in your body, roughly different kinds of bile, mucus, and blood. Later on, we thought that it wasn't liquids, but air that caused your disease, and this was a miasma theory of disease proposed fairly early on, but kept in circulation throughout the Black Death, as you can see from these plague doctors, all the way until the 1800s. Even while we were building the Panama Canal, people were thinking about that. In fact, malaria, the term malaria, comes from the Latin for bad air, leading back to miasma theory of disease. Germ theory of disease is what we currently believe, that most diseases are caused by living creatures, but we'll talk about a variety of other living creatures or other causes of disease shortly. I just want to point out that there's a reason I always start with history. Is that history has huge impacts on things that you wouldn't think about, right? So we talk about the four humors as this antiquated view of what diseases were, but this was in line with the worldview of the time, that maybe there were four elements or four seasons, and that you could break down the world into these four quadrants, right? Zodiac is divided into four different kinds of signs and three parts of each, and so on and so forth. And we tend to still talk about this moving forward, right? So even personality types in the 28th century, attitudinal values, they tend to break things down into fours, and you can draw a pretty direct map to the four humors from the Hippocrates. Just to show how history matters, right? Like even the Fantastic Four, the four Ninja Turtles, the four Six and the City characters, all have temperaments that you can draw a direct lineage to these four humors. There is the choleric, the angry character, and the phlegmatic, the bland character in all of these quartets. So I said that germ theory of disease is how we think communicable diseases are caused, but we also think that there's also other ailments that affect us. Or you can have genetic ailments having to do with chromosomal abnormalities or genetic abnormalities that cause people to have various degrees of ailments throughout their lives. Some physical factors can cause diseases. Exposure to cigarettes or UV or radiation can cause different kinds of cancers or radiation sickness. The biggest cause of death in the United States is diseases of lifestyle, heart disease, diabetes, obesity. There's also diseases that might be caused from consuming bad things, putting bad things in your body via um, food or waste. And finally, infectious diseases, which we can transmit to each other. Keep in mind, all of these can influence each other, and some of these can be caused by multiple things, right? So you could be predisposed to lung cancer or heart disease by your genetics. Your lifestyle could affect the food waste vector diseases you get, et cetera, et cetera. Infectious diseases could affect your lifestyle. So germ theory of disease. We've isolated microbes in the 1600s, van Leeuwenhoek, where it was able to see them under a microscope. But it wasn't for another 200 years or so that people thought that perhaps those microbes could cause damage. And Ignaz Semmelweis in the late 1840s and John Snow, who knew nothing, was yet able to figure out that people that were exposed to either corpses or to diseased water could get ill. And in fact, Semmelweis suggested that the doctors that treated corpses before they delivered babies ought to wash their hands because otherwise they would infect the mothers and possibly kill the child and the parent. He suffered quite a bit from that. It's sometimes called the Semmelweis effect, where you tell truth to power, and doctors said they did not, gentlemen could not cause diseases, and so Semmelweis was ostracized. But by the late 1800s, germ theory of disease was fairly well accepted, and there were some postulates that went along with it. Basically, the idea was microorganisms should be isolated from a disease, but not healthy organisms. They ought to be grown separately and then reinfect healthy organisms. And that infected organism, or the organisms isolated from that reinfected host, should be identical to the wild type. That way, we know that that particular microorganism causes that particular disease. This is all well and good for microorganisms, but there's also weird just lumps of genetics wrapped in protein coats. We call them viruses, that around the same time we started realizing were much, much smaller than bacteria. So in the tobacco mosaic disease, you could filter out bacteria from the sap, and yet the sap could still reinfect other plants. We eventually discovered that these were little particles that were obligately parasitic and that could cause disease. So when we looked for the microbe, the bacteria that caused the 1918 pandemic, we were looking in the wrong direction. It's not for 15 years after the 1918 pandemic that we were able to actually isolate that virus. Okay, now let's talk about plagues. So I want to make some distinctions here before we go on. There's a distinction between endemic diseases, epidemic diseases, and pandemic diseases. Endemic diseases constantly occur in a population. Colds, chickenpox in some parts of the world, perhaps HIV or tuberculosis. Epidemic diseases are diseases that rapidly spread, usually within a country. Pandemic diseases spread across multiple countries and continents. So they are big epidemics. This is important because we tend to be really bad at jumping from our understanding of diseases, i.e. colds or flus, to genuine epidemics and pandemics. We tend to we tend to think that new diseases that we face will be like the old diseases that we face, when in fact they can be quite different. So there's been a lot of historical plagues. Some of them we've been able to isolate and figure out what caused them. Some of them we have pretty good guesses. And you can go back over several hundred or thousand years and see literature that shows that these plagues ravished the countryside, right? Like the Black Death um, was the cause of Isaac Newton not being able to go back to Cambridge for a year. And in that time, he wrote everything that we know him for. Or Shakespeare, quarantined during the Black Death because everything was shut down, also was able to write some very important plays. These diseases, I mean, it's hard to visualize some of them, but they killed huge percentages of the population. And some of them, for example, AIDS, are still ongoing. In fact, as we'll see in the next lecture, the 1918 flu still forms the backbone of a lot of our current day flus. So there's a lot of features of diseases that are relevant. We tend to talk about the reproductive rate, sometimes called the R0 factor. And that means how many people a person can infect. At the low end, something like the Middle East Respiratory Disease or Syndrome, MERS, each person can infect, for every 3 people, 1 person is infected, or possibly 2.5 people are infected, roughly. Measles, on the other hand, is extremely infectious. Extremely. 1 person can infect dozens. And that's because the surfaces that you touch with measles could infect other people. There are diseases that are not deadly at all. The common cold is very, very rarely deadly. And there are diseases that are extremely deadly. Ebola, for example. There are diseases that last a very short while, and there's diseases that will stick with you for the rest of your life. There's diseases that you only spread when you have symptoms, whereas there's diseases that you can keep around you and spread without ever suffering from them. And finally, there's diseases that can incubate within a day, or shortly, or it can take years to show up. And so you can map these up. You can map every disease along all of these axes, right? We might create a disease space across a number of dimensions. Here are 2 of them, infectiousness and deadliness. And as you can see, there are these, quote, endemic diseases that are hard to get rid of, that are very infectious, but persist at a very relatively low rate. Measles, for example. We have a vaccine, but it's not universally used. That'll come up in this class. All of those stick around for quite a while and are hard to get rid of. And then there are diseases that become in epidemics. So if something is extremely deadly and extremely infectious, perhaps a zombie outbreak, you can easily see how it could take over the world. We are lucky that the current disease that we're facing, COVID-19, is somewhere in the cholera to treated HIV range in terms of deadliness and infectiousness. There are several diseases that have been just a little bit worse, like smallpox, tuberculosis, These have devastated the world. Another axis that might be of interest is different age and demographic mortality. So some diseases, this I think is HIV, could, or sorry, 9 infectious diseases. HIV is the next slide. Some diseases really, really affect older people. Other diseases really affect younger people. And we can see that particular mortality of different diseases has increased or decreased over time for a variety of reasons. We'll talk about that later on in this class. Okay, I'm going to stop here and start the next section in another video.